Good afternoon and welcome. This is part of the OSGi community event, and it's our afternoon sessions. And I wanted to introduce myself. I'm John Aries. I'm the OSGi Alliance Executive Director. And if you're not a member of the OSGi Alliance, I certainly hope that you would consider joining. You can learn more about what we do, which I think we're doing some fantastic work, at our website, osgi.org. We can always use the help, and if you're interested, see us there at the website, or come talk to me afterward. I'd be happy to talk to you about it. But again, thank you and for coming and welcome. And this session is on OSGi ecosystems compared on Apache Karaf, presented by Schneider from Talent. He is, do a quick intro. He is an open source architect at Talent. He was the responsible architect for the services-oriented architecture, ENBW Trading GmbH, a trading floor of one of Germany's largest utility companies. He specializes in OSGi and practical integration solutions. He was a regular speaker at several Java conferences in Germany like JAAS, WJAAS, and Apache Karaf. Please join me in welcoming Christian. Thank you.
Thanks. So, welcome again to my presentation. OSGi ecosystems compared. So the idea is to compare basically I even had a third at first, but now I limited it to two major ecosystems for creating applications in OSGi. It's Blueprint and Declarative Services. I planned to also include CDI, but till now CDI still has some problems on OSGi, especially on the JPA side, so I skipped that and can for the time being say rather avoid CDI until it's a bit more mature. In the morning there was an interesting presentation from Emily Young from IBM about new developments in CDI, so maybe it's improving, but we'll have to wait for that. So for the moment it's Blueprint and Declarative Services. I will show the applications on Apache Karaf, which is a quite popular OSGi server, which brings some convenience to OSGi, which we will later see. Yeah, from my side, I'm involved in a lot of the Apache projects, not so much in Eclipse till now. In Apache, it's Karaf, CXF, Camel, and Aries, where I'm committer and partly PMC member. And we drive in the team where I'm in the developments at Apache to basically provide the basis for our commercial software. We write at Talent, which is integration solutions. So we also use Apache Karaf, so it's quite near to what we also sell to customers, so it's really production ready. So I would like to shortly introduce Declarative Services and Blueprint and describe some of the properties it has. And to make it more life-like, I will show it on a simple enterprise application which covers some of the typical things you want to have in an enterprise application, like configuration support, JPA and transaction support, and also REST and SOAP services, and also UI integrations. And I will also show how to package and deploy on Apache Karaf, and show how to develop on Eclipse without any additional plugins. It's just plain Eclipse. And in the end, I will show some recommendations which framework to use in which cases. And if there's time, some ideas about enhancements for future. So coming to the application, it's a quite typical thing. It's a bit layered by quite horizontally. You should not forget that this is just a demo. In real life, you should rather layer more vertically, but to nicely separate the different technologies, I layered it more vertically in that case. So the basis is the model bundle, where we have a simple task entity. So the application is about managing some tasks like to-do lists, and the task is representing one to-do. Then there's a task service interface, which handles basically the persistence of tasks. Maybe a better name would have been task repository, according to model-driven design, but it's for a long time now service. Then the next model is the persistence bundle, where we have the implementation of the task service and the actual interaction with JPA. All the other bundles will have no interactions with JPA. And this bundle provides an OSGi service with that interface, and it's reused from the service endpoint, which adapts to REST in a separate bundle and uses CXF for that case. And also the very simple servlet UI, which just displays the tasks in a very small servlet. And a more advanced UI is using AngularJS and uses the REST service to interface with the backend. So declarative services, one of the injection frameworks we can use is designed around components. A component is on the class level, so each class can represent one component. And at build time, you can read the annotations and create an XML descriptor, and the XML descriptor is what is deployed then to the runtime. So there is a dynamic life cycle, so each component can start and stop individually, even if they are in the same bundle. And what is nice is that these annotations you can use for DS are all standardized in the OSGi specs, so you don't have any additional dependencies. And it's really small from the runtime perspective, because the SER implementation, which implements declarative services, is just one bundle, and so it's really easy to install in any framework. The bit bad things are there is no support for interceptors, which we see on the other hand for Blueprint. Typically, when you do JPA, you want to have interceptor around your methods for example, the transaction management, so starting and committing transaction or rollback. You would not like to do that yourself. There is some solution now with closures, but it's still not as nice as in Blueprint. There's also no extension model, so declarative services is just as it is. There is no way to provide, for example, additional annotations that will also be processed, at least not in the core model they use. So it's less extensible. The component lifecycle in DS is very interesting. So if you start with a component A that is referencing a mandatory service B, at the start the component will be deactivated because it's waiting for the service B. Then if the service B appears, the component will be activated. And if the service B disappears again, the component will be deactivated. And if you have kind of cascades of components that depend on each other, they will all go down when mandatory services go down. So it's really dynamically, which is nice because inside the components, this means you don't have to work with all the dynamic because you're just offline if something is missing. So it makes it quite easy to use services. So I'll skip that and show it in the code later. On the Blueprint side, it's much more like Spring. It's also the roots of Blueprint. We have an XML context where beans are described. Each bean represents a class and can be injected with other beans. And basically, probably everyone here knows Spring, so It's nothing really new. It's just some new elements for providing services, for consuming services, and the configuration management is also a little bit different, but it looks a lot like Spring. The nice thing is, let's first look at the configs. The configs are per context, exactly like in Spring. You have property placeholders and can inject configs into the properties of beans. But it's all per context. So if a config changes, the whole context has to restart to reflect this. While in Declarative Services, each component could be provided with a configuration and could be restarted individually. The nice thing about Blueprint is there is an extension model using namespaces, but this is not standardized. It's just Aries Blueprint, or Gemini Blueprint has its own extension model, but they are not compatible. The nice thing is you can have many extensions that already are present and that help you with certain technologies, like Aries JPA has some extensions, transaction, CXF, Camel. There's also an authorization plugin where you can use annotations like roles allowed to protect methods. So it's nicely integrated with many other frameworks. It also supports internal wiring. A component in DS is always a service that is published as a service. So everything is kind of public, while in Blueprint there's also internal wiring. You can have beans that are injected into other beans that are just inside the context. So that's a bit of a different model. And also there are interceptors, so which makes transactions and JPA usage really nice and easy. On the bad side, there are no standard Blueprint annotations. There's one older annotation model in Aries, which I don't like too much, and a newer one where I also created the first implementation in form of a Maven plugin, which I'll show later, which uses CDI and Java E annotations, but it's all not standardized, so it works nicely, but it's not a standard. And the other thing is the life cycles per context, so it's always has to restart the context when something happens. And there's also service damping, which I'll show here. So we had the lifecycle model in Declarative Services, which was completely dynamic. In Blueprint, it's a bit different. If you install a bundle with a context A, which needs a mandatory service B, it's going into a grace period, which means it waits for some time till a timeout. By standard, it's 5 minutes. If the service does not appear, it goes into failure and will not come up ever again. So it sounds bad. It's in practice not that bad, because normally you will provide services during startup, and so it's just an issue while starting up, so it's not really that problematic, but it's a possible failure point. When the service B activates, the context and bundle is also activated for us. If the service B goes away, the context is not deactivated, it stays active. It's just the service you get injected is a proxy, which does service damping, which means if the service is not available, it will block until a timeout and then throw an exception. So you may need to have to handle these exceptions. It's also normally not happening that often, but if you, for example, do a real-time application, and the blocking might be a real problem then, because if it blocks for 10 seconds and, for example, something real-time depends on it, that's not working. So this is a possible case where you want to have DS rather than Blueprint. For normal enterprise applications, it's normally not really a big issue. So I showed that or told that there is a new Blueprint Maven plugin that allows to use annotations to configure your config instead of XML. And this is the Blueprint Maven plugin. It's part of Aries too. So you use your standard set of annotations like CDI, Java E, and some PAX CDI annotations for the services part that is not yet specified in CDI. So most of the configurations you do is standard annotations, and the build result is XML, so it's a bit like in DS and quite convenient. So I think that's the point where we can switch to code. My presentation has some more slides, which I cannot show all because the presentation was normally for 1 hour. We have less time. So I will leave it in the presentation, so you have a bit more to read about, but I will show the important points in code here, because I think it's more practical to see it live. So let's first start with the Eclipse checkout. First, to get all these projects in Eclipse, it's pretty easy. You just start a standard Eclipse, no special configuration, no special plugins. Use import existing Maven projects. Go to the checkout. For example, if you use the example where you cloned it, and I think yes, the blueprint. So I just use the top level directory, leave it at default to import all, and there I use the name template group ID artifact ID because my artifact IDs are model or persistence. It would clash with the other example, so it's better to have a full name here. I import it, and basically that's all. You can leave out that blueprint Maven plugin. The new version will also take part in the incremental build in Eclipse, so you will not get this this warning anymore. For now, you can just say to exclude it from the incremental builds in M2E. So basically, you can just check it out and work with it. So this is the parent POM. It's a bit limited here from the screen. So basically, it lists the submodules, and I define some common dependencies here that are used by all the subprojects. For the most part, it's just spec bundles. Also for testing, I define the tests dependencies once, so I don't have to repeat them in every subproject. And the main things we have to include is the Blueprint Maven plugin, where I configure which phase and goal to run, and the version. Compiler plugin to set the version of the compiler, and the Maven bundle plugin to create the actual bundle information, so the manifest files. We do not do manifest first, so you typically do not never edit manifest files. You never edit them. You just edit some rules maybe. And if you don't have to do anything, you can just use some empty OSGi BND file. If you want to declare some additional imports or exclude something, you would do it in this file. You don't have to use that, but it's a good practice, and it's a bit nearer to how BND tools work, so it's a good preparation if we in future can hopefully use BND tools with that use case too. Yeah, so that's the parent POM. So now let's look from bottom to top. We'll start with a model. The POM of the model is really small. It's just saying this is the model. As we're using the Maven bundle plugin, we have to switch to the bundle packaging. And there is nothing else declared here. So for the OSGi settings, we have to tune that a bit for our model for JPA. And this is done in the OSGi BND file. And we set meter persistence to meter and persistence XML. That's it's part of the JPA spec in OSGi. to mark a bundle as containing a persistence unit. So Aries JPA will scan these bundles for persistence units and will automatically provide an OSGi service for the Entity Manager factory and also for a thread-safe Entity Manager. And for Hibernate, we also have to import the Hibernate packages for the enhancement. So it does runtime enhancements and will add basically or change the classes to use these packages in addition. So the Maven bundle plugin does not see that in the original source code or classes. So we have to provide that in addition. Normally, we would not have to change anything here. So that's the OSGi settings. And from the JPA side, we have a persistence XML, which is, for the most part, a standard persistence XML. It's not much special for OSGi. The provider class name is referencing to an OSGi service of type persistence provider, which is also part of the OSGi JPA spec. So a good OSGi ready persistence provider should provide an OSGi service with that name and would be found then by Aries JPA. Our data source is referenced with that. It's a JNDI name, so it can be looked up as a service. So basically that's another spec that says how to map OSGi names to OSGi services, JNDI names to OSGi services. So this is the interface, and these are arbitrary filters for properties. So basically, we expect a data source that has the OSGi JNDI service name task list, and we'll see later how that is provided. We only need the JTA data source. Non-JTA would only be needed if transaction type is set to resource local. Normally in OSGi, when you deploy to Apache Karaf, you should always use JTA because it's really easy to use the JTA level and it's not really slower. These are additional settings for Hibernate to create the correct dialect for H2 and to auto-create our schema. But that is all standard JPA. And it's the same thing for the classes we have. It's just a normal JPA entity class, nothing OSGi specific here. In fact, this model bundle would also work in a normal Java EE context. And the same thing for the interface. I'm not actually using that at the moment. This would mark it as a SOAP service. And apart from that, it's a plain Java interface. I typically use the convention to put interfaces for the model also in the model. Some people would separate that. I think that's a bad idea because the model is only complete when you also have the interfaces to work with it, because the plain entity class is not really enough. So that's all for the model. So for the most part, it's standard Java. Then it's a bit more interesting in the persistence part. The POM again is really small. We of course need a dependency to the model, and the rest of the dependencies is just for test. And there we configure the Blueprint Maven plugin to scan a certain path. So it's only active on paths you define and on subpaths. And what it does is it looks into the classes in that package and creates the blueprint from it. So basically this looks a lot like a Java EE definition. Apart from the top part, OSGi service provider is from PuckCDI. It says this should be exported as a service with the interface task service and with some special properties. This property here is to enable it for remote OSGi. If you don't use remote OSGi, it's not necessary. And singleton is used by the Maven bundle plugin to mark it as a bean. Oh, we're already at that point. I'm too slow. At transactional says I want the transaction handling, which is a required transaction by default. I can override it to transaction type supports. So basically, this is all standard Java EE annotations, and the Maven bundle plugin creates the blueprint for you, which is placed in target classes, but we should skip that a bit to be faster. So init helper is another class. It's just there to add a sample task. So we see again singleton add inject says inject another bean. If I want to inject an OSGi service, I would say inject add OSGi service. So also again quite near to CDI. Post construct is also from CDI, which says execute that when the bean is coming up. And it's all really nicely translated to Blueprint. Then we have the service. We're using CXF for that. Basically, for CXF, you have again the singleton from the Blueprint Maven plugin and consumes, produce. That is all CXF stuff. Here we inject the task service really as a service now. And the rest is standard REST. So you don't have to change your model of working. It's all like in non-OSGi. The last part is the Angular UI. The nice thing is you can just have the index HTML and app.js from Angular and just have to set this web context path. So it says the resources in here should be on that web context path. Pretty simple. So to show something, I will use that to install in Karaf. These are just some Karaf shell commands. And so now it's installed. This is the REST service, so it lists our resources. This is the Angular UI. We can also add something here. And it's in persistence too, so the REST service also reflects it here. So that is the blueprint part. And from DS, I should be a bit faster. The model is exactly the same, no difference. In the persistence, we don't have this add transactional or add persistence context support, because that is all something that only Blueprint can do with the interceptors. Instead, there is a JPA template, which is not a standard, but provided by Aries JPA. And you can say, execute a closure inside a transaction. So by default, it's a required transaction. You can also say it should be supports. So it's the same model, but a little more verbose because we have no interceptors. But it's a lot better than, for example, with Gemini JPA, which has no real support for that. So it makes using JPA with DS not as nice as Blueprint, but usable. So the service, this is also something, as we don't have the CXF integration in DS, we have to use a bit of a trick. There are some ways to adapt a service to a REST service, and one of these is to use remote OSGi. And this is what I use because there is a remote OSGi implementation using CXF, so it's very near the Blueprint example. But you don't have that much control over what CXF does. You can tune some things, but it's less thought out than the normal CXF support in Blueprint. So what you can do is say, I want to export all interfaces. That means I want to take part in remote OSGi, and exported configs means I activate the REST support of the CXF OSGi implementation, and this is where to put it on the path. So basically it works the same way as the Blueprint one. The difference is here to inject the service, I use @reference. To export the service, I use @component. But it's quite comparable. And yeah, the rest stuff is the same because it's also passed by 6F. And from the UI side, I have here in that example a very simple servlet UI. Nothing you would want to do in production probably. But it also uses the service model, so it's a whiteboard model from Pax Web. This means I can just export a HTTP servlet as a service with that interface and say this is the alias, so this should be exported as /task list, and Pax Web picks up that and exports it. And again, you can use the task service with @reference. So as you see, the whole application is nothing complicated. Most of it is like in outside OSGi world, and it's all completely Maven based. So if you want to build it, you just go to the parent and say run Maven install, and it's done. So do we have anything more there? No. So I think we can also look into the demo for DS, and there again some shell commands. The first loads the data source configuration, which I should show maybe. This is something from Pax JDBC. In the past, it was really difficult to configure data sources in OSGi. The first step was to use Blueprint, which made it a bit better. But now there is Pax JDBC, and you can just create a config with a certain PID, and it will automatically pick up this config by the driver name. It will choose the correct database driver, and with a URL and data source name and user password and pooling configs, and it will create from this config a data source that is fully ready to participate in XA transactions and in pooling, so it's really production ready. And Pax JDBC, you can look into the documentation of it to see exactly how it works, provides all the wrapping that is really easy to use. So there's not much to set up nowadays. And in fact, here I'm copying it directly from GitHub and installing in Karaf. So I'll do that. Oh, I missed one important part, the features. That's where you tell Karaf how to install the whole thing. The features are rather simple. This is a feature repository which can contain several features. It can refer to other repositories, so you can use features declared by other people. And I can say this is the main feature for my application with sub-features, and the persistence feature, for example, installs a SCR feature for DS, Aries transaction, Aries JPA, Hibernate. I can also limit the version of the feature, and Pax JDBC H2 config, pool DBCP, that makes it complete for this automatic wrapping of data sources. And then I have to specify my own bundles as Maven URI. So I just have to put the bundles into the local repository at build time, and Karaf can take them from there. So it can use your local repository and also your company Nexus repository. So it's quite scalable and works also nicely inside bigger companies where you have no internet access. For the service here at DS, we need Declarative Services implementation and the 6F DOSGi implementation, this remote OSGi. And again, just the bundles we need, and the same for the UI. So it's pretty simple to do, and in Karaf, you have this nice shell with history, with tab completion, with feature install help, with built-in help system, so it's really convenient to use. So that's the presentation part. So I'll just finish up. I was not able to present all. So the recommendation is for CXF, if you use frameworks like CXF and Camel, it's maybe the better choice to use Blueprint. Also JPA and XA transaction support is a little bit better, but it's only a small thing, so we have both options. And you don't have all of CDI in Blueprint, but a subset, and it's working pretty well. So it depends if that is okay for you. And for DS, it's if you need the dynamics, it's a good idea. And the config support, I was not able to show. DS has now type-safe config support. You can see it in the example. If you look into it, which is really nice, you can have support for the meta type automatically generated. The config is validated and updated at runtime. So the config support is great in DS now. And yeah, the integration with other frameworks is not so good in DS. So future developments. We're working on a Blueprint model to generate from your own annotations. So the Maven bundle, the Maven Blueprint plugin should be able to be extendable. So you could define your own annotations and do other stuff with it. That is not possible at the moment. We want to create OSGi indexes from the Apache projects that are then usable in BND tools. So the idea is to have the BND tools experience for everyone who looked into BND tools together with good Maven and Karaf support. So that's a major point. If we can do that, it's, I think, a big improvement for productivity. Yeah, and it will make the features easier because when we have that index, we can use the same resolver as in BND tools to just define top-level requirements for the features, and it will resolve everything that is needed. Yeah, that's it.
All right, we have to wrap up.
Exactly.
But I wanted to thank you very much. Appreciate the fine presentation. And thank you all for coming. But we're over time, and the next session will be starting soon.
So about the questions, I will be simply outside, and you can ask me outside. So to make
Come on up.
space.